Welcome to this video. Let's make a nice table, one that would get you full marks from the IBO for your internal assessment. So to begin for this activity, you're going to insert a table that's 5 by 7. So in this document, you'll go to Insert, Table, and we want 5 columns by 7 rows. There we go. And the headings always go at the top. And things look really nice at the top of your table if you have it like centered and emboldened. And up at the top, this is where we'll put all of the information for the users or for the audience to understand what you did. You start by listing your independent variable in the first column. And so I'll put the heading for the independent variable. This was the radius of the circle. And IB expects you to have a symbol to represent your independent variable. In this case, it's radius, so I'm going to use lowercase r. And then undo that capitalization. I want to use a lowercase r slash. I'm going to put the units for this measurement, and everything is in centimeters. Units only should be at the top of the table. You don't want to populate the entire table with a bunch of units. Okay? And then you need to include at the top of the table, you have a heading, we have the symbol for that quantity that's being measured, slash the units, if it's applicable. We're going to also include the uncertainty. So to represent the uncertainty, we are going to insert a symbol. We're going to use the delta symbol. This is a Greek letter. You may not see it immediately if you have not used it lately. So just in case you don't see it, I'm going to insert symbol, click this little lowercase arrow, more symbols, and this should be under Greek and Coptic. And if I look in my Greek and Coptic subset, I should see the delta. I gotta scroll up. Delta symbol, where are you? A, B, C, D. Come on. Here we go. Here's my delta symbol. And then insert and close, and you'll see it's here. Delta R. This lets the reader know the uncertainty in the radius equals, and then I'm going to get the plus or minus symbol. The plus or minus symbol is in the Latin 1 supplement. Plus or minus symbol, insert, close, and then I put the uncertainty from my best, or from my simulation. For me, it was plus or minus a 1/100th of a centimeter. Okay. And then I would just simply type my values into the column. For example, whatever this was, 0.50. And notice I don't have any units next to this number. I won't have any units in the number. The units are at the top of the table. All right, so these 3 columns are for my 3 trials of the dependent variable. But I want to clean this up. I want to make it look nice. So I'm going to highlight these 3 cells, and I'll right-click. Then I'm going to go to merge the cells. I'm now going to right-click this new merge cell, and I'm going to click split cells. And what I want to do is split this into 2 rows, 1 column, 2 rows, bam. Now up top here in bold, I'm going to put the heading for the dependent variable. This is the circumference. I'm going to label this capital C, and then the units for the circumference in centimeters. And then I'm going to put the uncertainty in the circumference measurement. Again, insert symbol. Now you should have this delta. Delta C, the uncertainty in the circumference equals, again, the plus or minus symbol, 0.01 centimeters. Now I'm going to come down to this split off part of the cell, and I'm going to click split cells again. And this time I want 3 columns, 1 row. And in bold, this will be my trial 1, trial 2, trial 3. Okay? And up top here, this will be my average circumference. same thing, c/centimeters. And then we're going to have the uncertainty in the circumference, and the average circumference, I'm sorry. Before I can get this average circumference, I'm going to need to fill out this table and get my average values. Once I do that, I'll be able to show you how to calculate the uncertainty and the average. Presto changeo, my table is magically filled, and you'll notice everything looks correct because all of the decimal places match the decimal places, the number of decimal places in the headings. Okay, so the last thing I need to do after I've calculated my averages and plugged them in is get the average uncertainty in the circumference. The textbook, the Cognitive textbook, tells you to do it a certain way where you get the relative mean. However, I went to a training last year and I asked about just getting the largest range in the trial data divided by 2, if that is acceptable for the average uncertainty, and yes, indeed, it is acceptable. I think it's much easier to do rather than finding the relative mean. So we're not going to do that. We are going to just look at the biggest range in the trial data divided by 2. So what do I mean by that? You will analyze each row of your 3 trials. I can see that the range in this data for my first variation is I take the largest value, subtract the smallest value, and divide by 2. So for example, if I did 3.15 minus 3.14, that gives me 0.01. I divide that by 2, that is 0.005. I will keep going like that for each row of data, but if I just look, I can see that my 0.75 measurement would have a range of 0.02, and then my 1.0 radius value, these would also have a range of 0.01. So, for example, it looks to me like the biggest range in the trial data either comes from this row here or from this row here. And specifically, these 3 values, this is where I would take the range for these 3 values. Okay, so 6.29 minus 6.27 equals 0.02. I divide by 2. That's the biggest range out of all of my trial data is 0.02. Divided by 2 gives me 0.01. So just so happens that the average circumference uncertainty is still, insert plus or minus 0.01 centimeters. However, let's say if I did make a change, let's say this was 6.30. Then instead, the biggest range in my trial data would be 0.03 divided by 2 would actually be this. However, I didn't ever measure to 3 decimal places of precision. I could only be confident to 2. So IB would want you to round that up to 0.02. It's always better to overestimate your uncertainty. In this case, I'll go ahead and make the change. Typically, your average uncertainty will be larger. In this case, it will likely be the same or less than this value, but you'll end up rounding back up to plus or minus 0.01 centimeters. It works out like this because this is a simulation and we can just keep zooming in. In reality, if you were to really use a ruler, there would be much greater uncertainty. Anyways, I hope you found this video helpful. Be sure to watch the next video on making the graphs in Excel.